Okay, school descendants, we're going to do a quick video right now on 45, 45, 90s and 30, 60, 90s for your enjoyment on Wednesdays. So two just special types of right triangles is what we're really going to look at today. And everything's going to be kind of made up along as we go along. So no PowerPoints, none of that, just kind of going today. So sine, cosine, tangent, finding signs of missing angles and finding missing angles and missing sides is great, but if we can find faster ways to do it, that's what we want. We like to be a little bit quicker, and we like to get things done quickly if we can. So there are two special types of triangles that we can set certain ratios forth, and if we're given one side, we can find the other side. And that's a 45, 45, 90, and a 30, 60, 90 degree triangle. So we're going to start out with a 45, 45, 90 degree triangle. So if we have a 45, 45, 90, if we have a 45, 45, 90 degree triangle, it essentially means that we have this right triangle where our two acute angles are both going to be 45 degrees. Now, because those angle measures are the same, then the opposite sides of those angles have to be the same as well. It's kind of that isosceles triangle theorem that you talk about back in geometry. If two angles are congruent in the same triangle, then the opposite sides are congruent to each other. So what that means then is that the two legs, remember we talked about legs yesterday, two legs of a 45, 45, 90, the two that make up the 90 degree angle. It means that those two legs are going to be congruent to each other. So we're going to put an N there, and we're going to put an N there. Okay, so we've put an N, oops, kind of got my pencils all marked up here wrong. So we've put an N there and an N there, so we know the length of those two sides. And again, it has to be exactly the same. So we could go through the Pythagorean Theorem then and find out, okay, what does that third side have to be? So we would go N squared plus N squared equals C squared. So that's 2N squared equals C squared. Take the square root of both sides. So if I take the square root of this side and the square root of this side, we end up with C is equal to N times the square root of 2. So that's what the ratio is always going to be for this side, is N times the square root of 2. So lots of times what you'll hear is said, I've got a mask on right now. That was weird because I didn't have it on before that little edit in there, did I? Take the mask off. Somebody walked into the room and I didn't want to start over. So we've essentially got a 1-to-1 to the square root of 2 kind of thing going on here, where the side lengths are the same, and then you've got this square root of 2, and we'll really talk about that 1-to-1 to the square root of 2 when we start talking about unit circles. But when it's in this style, I like to think about it as n, and n times the square root of 2. So what this essentially means is then that I can give you really any length of any side of the triangle, as long as we know it's a 45, 45, 90, I can tell you that the length of this side is 8, and I can ask you to find the value of n and find the value of t. Find the lengths of the missing sides. Well, n is going to be opposite of the other 45, so n is going to equal 8. And then my t value, well, that's the hypotenuse, so it's going to equal, so t is going to equal, well, it's n times the square root of 2. My n value is 8, so 8 times the square root of 2. So those are the lengths of your two missing sides for that right triangle. Okay, let's look at another example. Okay, in this one, again, we're going to have that 45, 45, 90 again. So we've got 45, 45, and we've got a 90 again. So this time I'm going to say, let's say that this is 4 times the square root of 2. In this case, we want to find the value of x, and we want to find the value of y. I threw radicals in there. It doesn't really change anything. It's n to the square root of 2, so our n value is 4 radical 2. So that means that x has to equal 4 radical 2. It's the opposite to 45, so we're done with that one. The y value then is going to be n times the square root of 2. So it's going to be the length of the leg times the square root of 2, or the length of the leg. So y is going to equal 4 radical 2 times radical 2, which is equal to 4 radical 4, which is just equal to 8. So the length of that side is going to be 8. Okay. The next one that we'll look at then, and let's take this one and say, all right, now in this time, again, we've got a 45, 45, 90. But now this time, I'm going to tell you that this one is 3 times the square root of 2. So I'm giving you the hypotenuse. So anytime I'm not, we're given the leg, it's pretty straightforward. If you're given the hypotenuse, what I like to do is I like to say, well, we know that the hypotenuse is n times the square root of 2, and the legs are n and n. Well, if I can solve this, I'll know what n is equal to. I know my hypotenuse is 3 times the square root of 2, but if I solve that, I can know what my n value is equal to, and then I know that that has to be the legs. So to solve n radical 2 equals 3 radical 2, you're going to divide by radical 2. So you get n is equal to 3. So now we know our n value is 3, so this one has to be 3, and that one has to be 3. Yeah, and you're done with that one. Okay. Well, let's change it up for the last one just a little bit. And this time we're going to say that this is 16. And there's my 45. There's my 45 and my 90. Okay. Again, I still like to go ahead and label it as n. This is n, this is n, and this is n radical 2. Okay, so I can set that equal to each other. Again, I know my hypotenuse is 16, but if I solve 16 is equal to n radical 2, because that's the hypotenuse of a 45, 45, 90, I can go ahead and divide by radical 2. So that gives me 16 over radical 2 is equal to n. We can't have that. I forgot to hit record, for crying out loud, on my phone. So all of this is, you're not going to see my face for a while because, yeah, I forgot to hit record on my phone. But now I'm going to hit record on my phone so you can see my lovely face again. So there's my lovely face again now that you can see it again, and hopefully I can get it synced up. But anyway, so we're going to multiply by radical 2 over radical 2, so that's 16 radical 2 over 4, which is 8 radical 2. There's your solution. That's what n is equal to. So the length of this side is 8 radical 2, and the length of this side is 8 radical 2 as well. So that's 45, 45, 90. And again, the two legs are the same. The hypotenuse is n times the square root of 2. The other type that we have then, the other type of special triangle is what we call a 30, 60, 90-degree triangle. So that means we've got one 30-degree angle, we've got one 60-degree angle, and we've got one 90-degree angle. And please make sure you pay attention to where the 30, the 60, or 90 is, especially if I draw it. Drawings are not to scale, so pay attention to where the 30 and the 60 and the 90 are. So if this is 30, this is 60, this is 90. The ratios for a 30, 60, 90, it's 1 to 2 to the square root of 3. So we're going to use S's. So the side opposite the 30 is an S. You know what? I'm not going to use S's because my S's look like too much like 5. So let's use L. Okay, so that has length L. The hypotenuse, which is the side opposite the 90, is 2L. And the side opposite the 60 is L times the square root of 3. So you hear this one saying 1 to 2 to the square root of 3 a lot of times is what you hear this one. Now, keep in mind that the square root of 3 is 1 point something, something, something. So it's not as long as the hypotenuse. A lot of times we call the side opposite the 60, you'll hear me call it the short leg. It's the short leg because it's a leg. You'll hear me call this the long leg. The side opposite the 60, the long leg, and then the hypotenuse is the hypotenuse. So you've got a short leg, you've got a long leg, and you've got a hypotenuse. The short leg is opposite the 30-degree angle, the long leg is opposite the 60-degree angle, and the hypotenuse is obviously just going to be the hypotenuse. So you'll hear a lot of times 1 to 2 to the square root of 3 is the ratio, or 1 to the square root of 3 to 2 is the ratio for a 30, 60, 90. Again, 30, opposite the 30 is your 1. Opposite the 90 is your 2. And opposite the 60 is your L times the square root of 3, or 1 times the square root of 3 ratio. So again, we want to be able to find missing sides of 30, 60, 90 degree triangles. So here's our 30, here's our 60. So let's say that I give you the length of the side opposite the 30 is 4. We want to find the other side, so we want to find x and we want to find y. Well, if we want to label the sides, because we like to label things, this is our L, because it's opposite the 30. This is L times the square root of 3, and that's 2L. If you like to label things, that's fine. So we know our L value is 4. So my x in here is L radical 3. So x is going to be 4 radical 3. Y is equal to 2L. So y is going to be 2 times 4, or 8. So those are the length of those missing sides in that 30, 60, 90 degree triangle. So if you're given the short leg, pretty straightforward to do these. Kind of the same thing if you're given the hypotenuse. So here's our 30, here's our 60. This time I'm going to give you that this is 16. Okay? It's our hypotenuse. Again, if you like to label the sides, go ahead and label the sides. Here's my 30 degree. Opposite the 30 is L. This is 2L. And this is L times the square root of 3. So I've got 2L. So if we want to find the other two sides, again, more than likely in your book, this is going to be labeled find x and y. Find x and y. Because you're given the hypotenuse, 2L has to equal 16. Because the hypotenuse is equal to twice L. So L is equal to 8. So I can put an 8 here. That has to be 8. And then I know my L value is 8 now, so y is going to be L radical 3. So y is going to be 8 radical 3. And there's your solution. And you got to bounce around it sometimes. Sometimes maybe they wouldn't ask you for the short leg, but they just ask you for the long leg. Find the short leg first, and then find the long leg if they give you the hypotenuse. It's just easier. I mean, is there a formula for it? Yeah. Cut it in half and take it times the square root of 3. And if you can remember that, more power to you. Otherwise, go to the short leg, then go over to that one. Okay, the next one. You can probably imagine where this one's going. Here's our 30. Here's our 60. Here's our 90. This time I'm going to give you the long leg is 18. We're going to find x and y. Okay, so again, I'm going to label them. This is L. This is L radical 3. And this is 2L. Okay, so I know that my short leg, I know my long leg is 18. So I can find the value of L by taking L radical 3 equal to 18. So divide by radical 3. So multiply by radical 3 over radical 3. So that's 18 radical 3 over 3. 18, so that's 6 radical 3. So that makes this L, so x is equal to 6 radical 3. And now I have to go 2 times L, so 2 times 6 radical 3, which is 12 radical 3. That's my value for y. And that's with the 30, 60, 90. And again, just quick ways to kind of manipulate yourself, kind of around the problems. So I'm going to put 2 problems up here. I'll sing you a song. No, I won't. Maybe I'll whistle you a song. Yep, I can whistle. I've been having trouble whistling lately. These masks. I'll give you 2 problems. I want you to go ahead and find the missing sides. So here's our 30. Here's our 60. I'm going to give you that this side is 14 radical 3. And the second one, we're going to have a 45, 45, 90. And I'm going to tell you that this thing is 4 radical 6, just for fun. I don't know how fun it is. So I want you to find the missing sides. I'll find x, y on the first one, and r and q on the second one. Okay, so there are your solutions for those 2 problems. So there's 30, 60, 90, and 45, 45, 90. If you're still struggling with it, there are like 8 bazillion YouTube videos on these 2 things that show it differently than I do. And maybe 41.9 billion different views are probably better than the way I show it, but that's the way I show it, so deal with it. Tomorrow, law of sine and law of cosine. We will see you then. See ya. Bye.